So now guys, we're going to look at the radicals. This is something related to exponents, but not really directly, maybe indirectly related to exponential functions and all those things. Okay. But first of all, I would like to check with you whether you understand this thing and you can read it back to yourself. What do I mean when I say square root of x? When you see a symbol, I think symbol is not a problem. You can have any shape. But what is important, you must be able to say the meaning assigned it back to yourself. What do you mean by saying square root of x? No, I don't mean that. X exponent half is equal to square root of x. But what do I mean when I'm saying square root of x? That is where maths becomes difficult. When you learn it, but you don't get the meanings of things you are playing around with. All together? Yeah. I wish someone can write a dictionary of mathematics, which is more easy to understand than the ones which dictionaries of mathematics have got. When I'm saying square root of x, I'm talking about a number which when I multiply by itself, I know my answer. My answer is going to be x. That's what it means. Do you agree? When I say square root of x, I'm talking about a number which when I multiply by itself, I get x. So in this case, it's two factors. The square root is represented by this would be also. I don't want to say that now. This is what I have here is x power 1. But until yesterday, 1 was half plus half. What about today? It's still like that, isn't it? 1 is half plus half, isn't it? But according to the rules of exponent, this is x to the power half multiplied by x to the power half. What am I saying here? It says when I multiply x to the power half by x to the power half, I get x. Therefore, square root of x is the same thing as x power half. Now you say this means that. What are you saying? I said dog. What does dog mean? It means dog. That's a poor explanation. Square root of x is talking about a number which when multiplied by itself gives me x. Cube root of x is talking about a number which when I multiply by itself 3 times, I get x. Are we together? Okay. Now, related to this, you are going to get things like this. Things like this. Let's say we've got something like this. Then somebody asks you to express this in terms of the square root of 2. Express this in terms of the square root of 2. What do we need for this? We need a row of exponent which says x times y to the power a is equal to x to the power a, y to the power a. All together. So I need to express this in terms of square root of 2. But what I see inside here, I've got x times y. And the one of those can offer me 2. This is 4 times 2. Then I remember the radical is an exponent which is what? Rational. So which means now I can now say square root of 4 times square root of 2. What am I doing there? I'm just doing this. And my powers are half. Then, but I know that this is 2. Then, voila, I've expressed this in terms of square root of 2. That's one example there which is simple. Then, I've got that done. Are we together? Then let's try to do this one. I will inviting you to simplify this one. (18) plus square root of 8. I wanted to express this using only one radical sign. Simplify it and use only one radical sign. In other words, I want something like this, and there's something there multiplying, and there's something there underneath. That's the answer I want. I want an answer which is called that kind of a skeleton. Push the pen against the paper. Okay, someone tell me what to write here, the next step here. 2, 9 times 2 plus square root of 4 times 2, then square root of 9, 2 plus 4 times 2. Then what happens here? This is 2, this is 3. Isn't it? 3 of these, 2 of these. Added together, 5 square root of 2. All together? Okay. So that is important. Another thing which is important is the following, which I'm going to expect you to be able to do. Sometimes we are given an expression like this: 1 minus square root of 3. Now square root of 3 is an irrational number, so which means this denominator is irrational. So it might be necessary to express this fraction as with a denominator which is rational. What do we need for that? These are the following things we need. We need to remember that 1 times a is equal to a times 1. Somebody say, why is it reminding us this stupid thing? But that is important to remember. Also, you need to remember that a divided by a is equals to 1. We also need to remember this famous factorization. What are the factors of this expression? A plus b, a minus b. We need all those things. Then, in addition, if you've got something like this, we always have got an associated expression which is similar to this, which is a minus square root of b, and we call these two conjugates. Now, if you've got a number like this, and you want to get a rational denominator, you'll always need the conjugate of the denominator. Then, when you need to have the conjugate denominator, you've got to create a 1 this way, so that when you multiply this, you can satisfy this property. Do you see why I'm writing everything there? So we'll just say now this is 1 over 1 minus square root of 3. What is the conjugate? It will be plus the square root of 3. Then you write there times what? 1 plus the square root of 3 over 1 plus square root of 3. Then now what we're going to do, we are going to use this factorization, and then we are going to get 1 squared, which is going to be 1. Then we are going to get square root of 3 squared, square root of 3 times square root of 3. We are going to get 3. Then at the top we are going to have 1 minus, plus square root of 3. Now the denominator is just minus 2, and the minus 2 is rational. If you don't understand why minus 2 is rational, then you ask me later. So guys, we're going to deal with this also. Are we together? Okay. So I think if there are no questions, I'm going to stop there and urge you not to wait for me to give you exercises to work. They are in the textbook, they are in other textbooks. Please do that. So if there are no questions, I will say thank you for listening. For now, I'm going to stop there.